Hi, seventh graders. Today we're going to be subtracting our signed fractions and mixed numbers. So using subtraction with our positive and negative fractions and mixed numbers. Quick review for subtracting integers. All right. Remember that subtraction can be rewritten as adding the opposite. Okay, so adding a number's additive inverse or opposite is the same as subtraction. So you keep the first number the same, change that subtraction to addition, take the opposite of the second number. So in your notes, when we are subtracting fractions, first of all, you're going to want to find that common denominator if needed. And we're actually going to look at each of these problems kind of two different ways here. So one thing that we can do is we can always rewrite the problem by adding the opposite. And then once we have that addition problem, we could look at our signs to help us know if the answer is going to be positive or negative, and then follow our rules for adding integers, okay? So we'll do some examples that way, but then I'll also kind of talk a little bit about thinking of subtraction as distance as well. So 5/8 minus negative 7/8. We already have the common denominator, so that's good. So let's go ahead and rewrite this as an addition problem. So when I do that, my first number stays the same. So the 5/8 will stay 5/8. The subtraction becomes addition. The opposite of negative 7/8 is positive 7/8. So 5/8 minus negative 7/8 is going to be have the same answer as 5/8 plus 7/8. So now that I've done this, I can follow my rules for adding. And so 5/8 plus 7/8 gives me 12/8, which would equal 1 4/8, which is equal to 1 1/2. Just to show a different perspective of that same problem, you can think of subtraction as the distance between two values as well. So if you think of kind of a number line here, I'm going to put 0. So if I think of 5/8, it's going to be somewhere over here. And then I want the distance between 5/8 and negative 7/8, which is going to be down here. And so then when I think of the distance between these, that kind of shows you why you end up, so the distance from negative 7/8 to 0 is 7/8, and then you end up adding on that 5/8 distance as well, from 0 to 5/8. So just kind of another reason why this adding works, okay? Number 2, negative 1 1/5 minus 1 2/5. I'm going to actually model this one on the number line first, and then we'll rewrite it as the addition problem. So you don't need to do it both ways every time. I just want you guys to be able to visualize it too. So here's a number line. So here I want my distance between negative 1 1/5, and then the distance between negative 1 1/5 and the 1 2/5. And so again, you're going to end up seeing that we're going to be having this distance, which is going to be 1 1/5, and then this distance, which is 1 2/5, and we'll end up adding that. Now this one will end up being negative because our starting number is less than the number we're trying, the second number, okay? And so because it's less, then we end up getting a negative answer. Here's how we would rewrite this as an addition problem also. So first number stays the same, negative 1 1/5. Our subtraction becomes addition, and then we take the opposite of 1 2/5, which is negative 1 2/5. Okay, and then again, I would follow those rules for adding. So I have a negative plus a negative. I'm going to get more negative. So negative 2 3/5 would be my answer here. So again, just the number line is a good way to visualize that you need to add up those two values. Number 3, -1/2 minus -5/9. First thing we're going to do is find that common denominator, which would be 18. So 2 times 9 gives me 18. So I get -9/18 minus -10/18. So we're multiplying by 2 here. On this one for the number line, and again, you don't need to model it out both ways every single time. You don't need to model it and work it out. I'm just trying to give you guys some examples here. So 0, do a little bit more. So -1. So the -9/18 is going to be about right there. -10/18 is right here. And if I'm thinking about the distance between those, all right, the distance here is only 1/18. And then, so when I rewrite this as an addition problem, first number stays the same, subtraction becomes addition, the opposite of -10/18 is +10/18, -9/18 plus 10/18. I have different signs, so I'm finding the difference there of 1/18. And it's positive because the 10/18 is positive. -3 1/4 minus 3/5. We're going to find that common denominator first. So that's going to be 20. So -3 5/20 minus 12/20. And so if we imagine rewriting this, we have -3 5/20 plus, and then the opposite of 12/20 is -12/20. So we have same signs, so I'm going to be adding these, and I'll get -3 17/20. That can't be simplified, so then that's my final answer.